x-axis. Let me do the problem. So this is length L by 2, this length L by 2. Now what is the moment of inertia about x-axis? So it is, shall I say that it is similar to circular disc only. Moment of inertia about x dash is equal to mr square by 2. About y-axis, it's not a thin rod. So for y-axis, what you should do? You should assume a circular strip. Two symmetrical circular strips, I'm assuming it. Let it be at a distance x. Mass of this be dm. It's a cylinder. How you define volume density? Rho is equal to pi density equal to mass by volume. Volume is how much? Pi r square into L. Then what is the mass of this small element? dm should be equal to dx. So this is dm. So what is the dm is equal to? Mass of this should be equal to rho into pi r square into dx. This is the mass. So now I'll apply parallaxis theorem again. What is the moment of inertia of this cylinder about this one? First about the disk I'll calculate, then I'll integrate that one. So this should be, again, one more axis I'll bring it. Now why this axis p dash? So moment of inertia di is equal to moment of inertia of this disk about p dash. Because the axis passing through center of mass plus dm into x square. What is the about any diameter? How much it should be? Mr square by 4. So dm into r square by 4. Are you getting this part? Why dm r square by 4? Because this is a circular disk about any diameter. This is an elemental disk. Elemental disk, this one. About any diameter, how much it should be? Mr square by 4. What is the mass of this elemental disk? dm. Radius is r. So dm r square by 4. About axis pp dash plus this one. Parallaxis theorem I applied here. Like this, there are two sides are there. So therefore, shall I go for 2 times of this? Then I'll integrate from 0 to L by 2. So then I'll get the I dash. This is also very important. Just do make observation. Very, very important for us. About x-axis, very easy. Similar to circular disc. About y-axis, what happens? You should apply parallax system. Similar to rectangular plate. The idea of that. Do calculation. This is about solid cylinder. Hollow cylinder, again the same approach for hollow cylinder. Again, what you are going to do is,
So can you scroll? Okay, so thank you.
for hollow cylinder, so this is the again the same thing. So this is the hollow cylinder where the mass will be at a distance r. Let the radius be equal to r. This is y-axis, this is x-axis. About x dash, how much it should be? Only mr square. Again, when you go for y dash, what you should do? You should assume a strip. Ring you should assume. Not a disc here. Why ring? Because hollow cylinder, what it's made up of? Shall I say, assume that it's made up of rings? So again, this will be pp dash. at a distance x, the distance let it be dx. So again the same formula, I dash should be equal to about any diameter for the ring, how much it should be? Mr square by 2. Integrate this. Now why 2? Because two rings are there, no? We'll get I dash. Directly I'm writing it because just only simple integration is there. Need not be very complicated. Why dm r square by 2? Because about pp dash it is. So here di pp dash is equal to dm r square by 2. Like that about any axis. Once you know about the major things, no, you can find out all other things using parallel axis, perpendicular axis table. Okay, this is about the ring or that one. So next we'll go for the hollow solid sphere. So in books it is available. So again, it takes a lot of time integration also. Directly I write the things.
Sir,
Then
will
about
you scroll up once? Thank you, sir.
there's a solid sphere. About any diameter, what will be the moment of inertia? About any diameter, because I think it will become any diameter, no? What is the moment of inertia about x dash or y dash, or about any diameter also you can draw like this. There's a solid sphere of radius r. This should be equal to 2 by 5 mr square. This is what very important in MI moment of nature chapter. We use this very exclusively. In books they have shown. Just do remember. Just go through once. Okay, what is the method involved? Lot of some integration we are going to apply it. That mathematics I feel may not be help us anywhere that one. So straight away I'm just trying to avoid that mathematics. If you are interested, you can go through it. Okay, after this, now we'll go for hollow sphere. Mhm. Hollow sphere or thin spherical shell, it is called as. Where mass is present, it's a thin shell, or you can also call it as thin spherical shell. This is the R. So this is x-axis, y-axis. So we'll go for any other axis passing through diameter like this. So how much moment of inertia? Ix dash Iy dash equal to 2 by 3 m r square. Okay, now we know this much here. I'm going to take the application part here. What is the application part? I will cut this all those solid sphere into two parts. Then we'll see how conditions will come. Just can you remember 2 by 5 mr square about any diameter, and 2 by 3 mr square about this one. You cannot apply perpendicular axis theorem for 3D objects. I think I made the perpendicular axis theorem is applicable only for laminar objects here. For 3D objects, you should not apply it. So that, but parallel axis theorem is applicable here. Okay, let's take the first solid hemisphere. We'll take the problem for solid hemisphere.